Hi everyone, I'm Zuleyha, a PhD student in University of Leeds. Today I'll be talking about a part from my PhD project. So it's a compressive string of concrete with GGBS, ground granulated blast furnace slag estimation model. So first, I'll be talking about a bit model explanation and the interpretation. So we all say we can do data analysis to relate the string to mixed design, but here is the question, what database? In my project, we do use industrial database, which comes from our industrial partner, Sika. So, secondly, we can use machine learning methods to predict string and optimize the string. But what method? We do use multiple linear regression with interaction terms and variable transformation. So, string is affected by many factors, but what factors? There are many. And those factors have also interaction effect on the string. What interaction terms? There are also many. We will be talking about all later. So, our dataset is a big and consistent dataset because it is the trial mixes were performed in the laboratory, well-controlled environment, and we have used approximately 3,000 mixes for modeling. When it comes to interpretability and accuracy trade-off, actually we have seen that it doesn't have to be trade-off if we have well-specified multiple linear regression model. Our model has achieved 90% of R-square, and we have a regression equation which allows us to estimate the string and optimize the concrete mix design. So the most important factor, the most important thing in our modeling process, model specification. We first determine our main factors as well as interaction effects based on previous knowledge. And then we explore how incorporation of those factors into our model change the model accuracy. How they, each of them, each factor, contribute to model accuracy. So, selecting the key factors that influence the string significantly, and they have to make sense in terms of concrete technology. So here are the factors that we found. They are effective on compressive string. Those are related to aggregates. Those are related to binder phase and, of course, curing time. These are the main factors. Also, they have interaction effect among each other. And here are the effective interaction terms. But if we do not apply some variable transformation, we cannot achieve high accuracy. So, why we need this? We need to catch the nonlinearity of between some variables and the string. That's why we need to do variable transformation. Here, some of the factors need to be transformed. Firstly, water to binder ratio. Transformation of water to binder ratio, like inverse of water to binder ratio. So binder to water ratio works well in our model. Secondly, curing time. Using natural logarithm of curing time is a good option for transformation of these factors. Lastly, plasticizer content. We transform plasticizer content like using square of plasticizer content, and it did job as well in our modeling. So in a tidy version, this is the descriptive statistic of the dataset, our numeric variables and categorical variables. 5th percentile and 95th percentile of factors. It's a representative range for the variables. So now we will be looking at how our model reproduces the well-known effect of some factors. So as we know, GGBS, ground granulated blast furnace slag, is a latently hydraulic material. So in the first day of strength, the contribution to the strength of GGBS, not too much. Please look at the left-hand side and the one-day strength of counterplot of cement to water ratio and GGBS to water ratio. And see the arrows, the GGBS contribution to the strength, not much. And when we time pass, when we go to other counterplot, we see the contribution from GGBS. What about the well-known effect of crash aggregates? Here is the surface plots for concrete with crash aggregates, coarse aggregate and uncrushed coarse aggregate. And we can see clearly the blue one belongs to crushed coarse aggregate. It has a higher, greater strength than the concrete with uncrushed coarse aggregate. So we saw our model reproduces the well-known effect of GGBS and crash coarse aggregate. Let's move to plasticizer effect now. So here are some counterplots with superplasticizer and plasticizer. Let's look at the early stages of strength development. As we see, increasing plasticizer and superplasticizer, both of them in the early stages of strength, it doesn't give too much contribution to the strength development. But when we see the later ages, increasing superplasticizer increase also strength of compressive strength. Also increasing plasticizer increases the strength of compressive strength, but here we should be talking about an optimal level. It's around 0.5. Beyond that level, no need to put more plasticizer, because we can see it is an optimal level for plasticizer content. So here I show you our model for concrete, for compressive strength of concrete with GGBS, and I try to explain our dataset, our modeling process, and gave some interpretation of our model. So that's all from me. If you have any question, I'm happy to answer.